يعني ما راح يدخل في الاختبار. The same content. Okay, the defenses of this actually network, or what we call it, computer network or digital computer network, they are related to the issues we saw in the unit number 4, the network vulnerabilities and the methodologies used to achieve, to realize actually the network vulnerabilities with protocols. We saw all the techniques that was actually implemented. We see different defense mechanisms. Uh, this is the main concern. Actually, still we are going to define new systems of, let's say, systematic approaches to realize a secure computer network, step by step. So let's proceed. This is the preview of the objectives. The first definition we're going to define when we talk about the, let's say, the computer network is the context of the vulnerabilities, entry points. Still, we are talking about the updates as a concern. It's not only related to the computer systems. The updates, the concern of the updates is not related to the operating systems only. Why? Because the patch is a security update, and still we are facing it here in the context of the computer network. Why? Because the computer network is not a wiring or just simple interconnectivity or inter communication between parties, computers. A computer network, we will see a scenario via which we see a center point that controls the list of, let's say, endpoints, a server, which is a service provider that gives the access to different candidates, different computers, different mobiles, different, let's say, mobile devices, whatever they are, mobiles or laptops or things like that. So the security updates still represents an issue when you talk about updating an environment. Still, the security of this has to be set properly in order to avoid weaknesses and, let's say, misconfigurations. And those weaknesses and those misconfigurations, they lead to the vulnerabilities in question. The first security starts with the design. The first security here, the first security concern, the first security, let's say, solution. It starts with the context of the physical network. What does mean physical network? It means how we are interconnecting devices, how we are making the devices see each other. If we take the example of the here, the laboratory, the building number 8 in our campus, rooms, they cannot see each other. Students from, let's say, room number 81, they cannot share data with students from room 8, room number 8, number 85. So they are segregated. Physically, they are segregated. So the first security to set, we talk about the physical architecture, see the segregation, let's say, separation of network paths or trunks. We talk about the network trunks. Subnets, we generate subnets. The technology here defines the subnets as a solution for that. This context of subnetting or segregation of the network paths is based on the addressing as a solution. The addressing here means we are going to use the IP addressing, the IP, whatever the version is. We are going to use the IPs to separate devices. Why? Because all of them, they are belonging to the same network. Here also, the same example, we take the building number 8 in our campus, room number 81, 82, 83, 84, 85, 86. All of them, they are belong to the same network. They are connected to the CIS, the Center of Information Systems here in our campus. What does it mean? They are connected still. We are talking about segregation, but still they are connected. They are able to see each other. Whatever. So how we are going to separate them? Here, logically, we are going to assign different IP ranges. So we are going to consider given classes, different classes to each group. So based on the IP segregation, we talk about Based on the IP segregation, we talk about the network groups or network tracks. So the segregation is a matter of subnet at the end of the day. So we are going to change the network portion and the computer portion of the IP address in order to generate different subnets in order to succeed in splitting those groups here. So we can actually, this context of classful address and the change of the IP ranges, the number of the portion of the number designated to the host, we can split it anywhere in the sense of, actually, if you recognize the IP address, it's a must. We are going to give any number to the host and any number from the IP also to the computer part. There are rules here. There are rules, but all the segregations are admitted, are considered to be okay. We have to recognize the rules. Okay, examples to visualize this explanation. A physical preview of the the subnetting. Here we see actually an IP address that 196.98.34. See here, the same here, 196.98, but 33.15. Okay, 186, it's a class B. 186 class B. 186 class B. What does mean class B? What does mean class B? Class B means we are having two numbers for the host. Sorry, for the network, and also two numbers for the host. So the first number 1, number 2, they are for the network. Number 3 and number 4, they are for the host. Number 1, number 2, for the network. Number 3, number 4, they are for the host. So this way, actually, we can play on the range of IPs. So because number 1, number 2, number 3, number 4, we utilize them to designate what is the class we are in. So the play on those numbers, no more, no less. The numbers meant here, anywhere we are going to split the IP address, or the numbers to designate for the host or for the computer, they are those numbers here. Some terminologies. This concern here, when we segregate groups, group number 1, group number 2, let's say, and we may say group number 3 also here, it has some advantages, some benefits. The network traffic will be actually decreased. How? When we say computer A, for example, this computer is going to send a message to computer B, so the network peripherals recognize that this is the computer B. They will not search here, where is the computer B? Immediately they will search in this track. This way, the traffic would be actually decreased. Flexibility in the sense of, are we able to add other computers, for example, in this group? Yes, we can. We have to respect the addressing, and we add as many as the addressing allows. Yes, the flexibility is seen. Troubleshooting in the sense of, if any issue, for example, happens in this computer, in this server here, it would be actually very easy to recognize which one is responsible for the issue in order to fix it. Troubleshooting. So we not search all the computers. No, we will know that the problem, for example, comes from this group here, left one, the right one. So we will search, or the technicians will search in this group. So it's an easiness in the troubleshooting. And the IP addresses, this context of numbering here, this addressing, we will use, or the technicians will use, only the needed addresses, only the needed addressing range. They will not use more than the required. Again, like we are going to make it easy and less traffic. Also, the network devices will be utilized only the needed. It means technicians will apply only the needed peripherals to interconnect network trunks. Here we are talking about the minimal impact on external routers, because the the connectivity in between the trunks, we'll use a network device. And the connectivity to the external network, for example, we talk the internet, we need specific peripherals, routers, for example, modems. The address in here will facilitate this address in this subnet, will facilitate and will make the stress on the routers, the interfaces with the external networks less, in the sense of they will not be stressed when the communication is happening internally. So if internal computers will communicate, the peripheral that connects to the external, to the internet, as per example, will not be actually stressed. So minimal impact on external routers. And the physical network here, by subnetting it, by doing the subnetting, by going behind the subnetting, the physical segregation of the devices, the physical how they are located, will help the technicians understand the shape of the network. So the physical architecture, the physical nature of the devices will help the technicians understand how the network looks like and what are the members of the, let's say, given subnet, for example. Room number 81 in our department, in our college, in our university, we not host computers from room number 6. They are all from the room number 1, physically seen here, physically seen. This is the reflection of the physical network. Room number 1 we have only computers from room number 81. Room number 86 holds only computers from room 86. That's it. So physically seen, reflection of the physical network. I'm going to stop here. Because I have another exam now. See you next class. إذا اتفقتوا على if you just you are met on a different